Do you have the gun, guys? It's an old little stand and deliver reference, right? They do this little tic-tac-toe thing in stand and deliver, which is a shortcut for integration by parts. And so we're going to do a little Zorro method, right? An integration by parts, you guys, is what do you do when you get an integration problem where U sub doesn't work? Well, we have something called integration by parts when we have tougher problems, okay? So here we go. We're just going to get after it. And there's a formula for integration by parts, okay? There's a shortcut and a formula. So let's write down this formula right here. Let's say we have the integral of u dv. What the heck is that about? Well, it's like we do a little u with a v sub. That's actually kind of what it is, okay? And that is equal to u times v minus the integral of v du, okay? Memorize, 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 okay? And then we're going to backwards Zorro this thing. And the other thing that is so important, and they didn't teach this to you in Stand and Deliver, is this acronym Lippett. Okay, you guys write down what this acronym stands for right now, okay? L means logs, logarithm. I stands for inverse trig. P is for polynomial. E is for exponentials, and T is for regular trig. Logarithms, inverse trig, polynomials, exponentials, regular trig. Okay? And you've got to know that because that's what we are going to let the U be. All right? Because for all of these problems, you cannot do U sub. Try it. It gets you nowhere. So instead, we're going to backwards Zorro it. Okay? And the way we backwards Zorro is we rewrite this problem. We let U equal. Oh, snap. There's two things there. So U is going to be equal to something, and dv is going to be equal to something. Thus, we get the integral of u dv in that formula up there. All right, and U is going to be whatever comes first. Logs, inverse trigs, polynomials, exponentials, or trigs. And there's no logs in this one. There's no inverse trigs in this one, but there is a polynomial. So that is what I'm going to let my U equal. And how about it? The pen went out. That is just awesome. I will see you when I see you. Come on, man. I got to get this screen off first. All right, so let's roll. I got to go to this new screen. We're going to Lippett this bad boy, right? So we're going to let our U equal x because it's a polynomial. Then dv is going to be the other guy, which is the rest of it, which would be cosine x dx. On this guy here, the u, we're going to find the derivative. The derivative of x is 1 dx, right, class? Since this is dv, we're going to take the antiderivative of it. And the antiderivative of dv is v. The antiderivative of cosine would just be sine x. And then it would be plus c, but we don't do that in this, okay? We're going to add that c at the end. And then we backwards Zorro that bad boy. Okay, the backwards Zorro means this. Okay, your original problem are those two things, right? That's the original problem. And the original problem is going to be equal to u times v, so x sine x, minus the integral of that. Thus, we get the backwards z, right? That's the original problem, which is equal to uv minus the integral of v du, which is dx. Okay, and guess, so wait, I can do that, right? And then you're done. Seems crazy, but it actually works. Okay, that is just done, right? That's part of the formula there. And then the antiderivative of sine x, well, that would be negative cosine x plus c, right? I'm going to add the c now. So my answer is x sine x plus cosine x plus c. And you know what? It seems just crazy. But if you find the derivative of this guy, guess what you get as your answer? You get that original. If you don't believe me, try it, okay? We do have a shortcut for these bad boys where we can't do the shortcut until you know the long way. Why do we have to know the long way? Is because this will come up as a multiple choice question on the AP, and they will use integration by parts. And there are some problems where you can only, the shortcut does not work, okay? And only integration by parts works. All right, let's keep rolling. At some point in time, you know what? Hit that pause button. See if you can get some of these on your own, okay, class? It's the best way to make sure you get good at this. All right, Lippett, right? Most important thing with integration by parts is Lippett. Do we have any logs? I do not have any logs. Do I have any inverse trig? I do not have any inverse trig, but I do have a polynomial. The polynomial is 2x. That means dv is everything else, which would be e to the 4x dx, okay? For the u, we take the derivative, right? So we get du equals 2 dx. For the v, we take the antiderivative. Antiderivatives. Now, if you have to use u sub, you go crazy. But hopefully you've gotten so good at antiderivatives, you can get that as quickly as I just did. All right, and once I have all that stuff, what do? Zero! Okay, we do backwards zero, which that's the original problem. I like to read it off. I like to rewrite it just to make sure I understand what each piece of my backwards zero means. That's the original problem, which is equal to that times that, which is u times v. I'll write it out first. You could always simplify. Minus the integral of this, v times du, which would be 1/4 e to the 4x times 2 dx. I could simplify a little bit here. Let's make it look pretty. That would be 1/2 x e to the 4x. That part is donezo. Okay, this part here I get 1/4 and a 2, which is 1/2, and I'm going to pull that 1/2 out, right, class? Because it is a constant. Get a little something like that. We can find that antiderivative, and how about it? That is so awesome. It ran out, so here we go. We could find this antiderivative, right, class? Let me finish this one first. So we get 1/2 x e to the 4x minus 1/2. Right, what's that antiderivative? We kind of already did it. It's 1/4 e to the 4x plus c. So when I get a final answer here, it's 1/2 x e to the 4x, right? I'm using my finger, so I apologize. Minus, that would be 1/8 e to the 4x plus c. And then there we go. That's the answer. This seems crazy, but believe it or not, that dude right there is that original, and my pen doesn't work. That would be equal to this if you found the derivative of all this stuff. All right, see you in a minute. All right, I had to pull another bad boy out, so here we go. All right, let's Lippett this bad boy. U. Oh, snap, I got a log, right? So that means u is going to be the natural log of x. That means dv this time is the polynomial, which would be x dx, because it's what's left over, right? So du equals 1/x dx, right, class? And v, the antiderivative, would be 1/2 x squared. And you don't have to solve. Remember, u sub, we solved for dx, right? We don't do that here because we are just replacing some things, okay? We're just using this formula. And what is it again? It is the backwards zero. And the backwards zero is the integral of the original problem, which are those two things combined up there, which is equal to those two things, which would be 1/2 x squared natural log of x, right? Minus the integral of those two things. And what, are you serious right now? Look how cool this thing works out. Oh, snap, you can definitely simplify some things there. So we get 1/2 x squared natural log of x, x squared over x, and I have a constant. I'm going to pull that bad boy out. Oh, I just end up, are you serious? Is that really just it? So I have 1/2 x squared, the natural log of x, minus 1/2. Let's go ahead and do our power rule for antiderivatives plus psi. And then we get 1/2 x squared, natural log of x, minus 1/4 x squared plus psi. And guess what? Take the derivative of that bad boy, and it is that bad boy. I'm just going to keep on rolling. What's your job? Your job is to hit pause and see if you can get the next one on your own, even though it might be a little bit tough. Oh, snap, what do I do? It looks like I should be able to do that, right? We even had this on a homework question, or even, I think earlier, and you guys were like, we can't do that. We don't know the antiderivative of natural log. Now you got some tools so you can find it, right? We use Lippett. What the heck is that? Believe it or not, this is the integral of 1 times the natural log of x dx. Believe it or not, that's a polynomial, right? Y equals 1. It is a horizontal line. All right, so here we go. Let's do Lippett. Lippett is u is equal to a log. Ooh, definitely got a log. And that means dv is equal to a polynomial. In this case, it's just 1. That's why students struggle with this bad boy. So what is the derivative of the, well, that's just 1 over x dx, right, class? What is the antiderivative? Oh, snap, that's just x. Oh, easy peasy, Japanesey, 0. And you better be doing that, 0. When you use it, you've got to do the Zorro, okay? And the Zorro is, the original problem is that, okay, is equal to these two dudes, okay, minus the integral of those. What the what? It's x 1 over x dx. What the heck is that? So that's x natural log of x minus the integral of 1 dx. Well, what's that? Oh, I know that. Okay. Nice and easy, Japonesey. Okay, and guess what? Boom. I'm gonna test this. I don't believe Mr. Tanaka. I'm gonna take the derivative of that. Well, the derivative of that, okay, I'm gonna take the derivative of that bad boy, okay? The derivative of this right here, let's do blue so I don't confuse anybody. That would be a product rule, which would be x times the derivative of the natural log of x plus the natural log of x times the derivative of x, which would be 1, right? That's the product rule just there. And then the derivative of negative x is negative 1. And then plus c, well, the derivative of a constant is 0. So let's go ahead and do this. Oh, are you serious right now? Those guys go away. I end up with that is the original problem. Oh my gosh, Mr. Tanaka didn't lie to me. Sweet. All right, let's keep rolling. Oh, snap. There is an inverse trig. So some of you are freaking out. Let's check it out. Let's Lippett this bad boy. Okay, I like my red better, you guys. I'm going to switch that bad boy back over. Lippett, L-I-P-E-T. Is there a log? There is no log. Is there an inverse? Oh, there is an inverse trig. So that means I have to let u equal the inverse trig. So what the heck is dv there? There's nothing there, so it's just 1 dx. Okay, that's okay. I can do that. That means the derivative would be the derivative, and guess what? It's just of x, so that's just the formula, 1 over 1 plus x squared dx, right, class? And then the antiderivative of 1 is just x. And then we Zorro. Okay, we Zorro that bad boy, which would be the integral of the inverse tangent of x dx, which would be equal to those two guys, x inverse tangent of x minus those two guys, which would be x over 1 plus x squared dx. Oh, sweet, right? If that was a standalone problem, you guys would dominate that bad boy. That is simply a UU sub. I technically used U already, so let's make it W sub. So I'm going to let W equal 1 plus x squared. That means dw equals 2x dx. That means dx is equal to 1 over 2x dw, right? And so if I'm just taking this piece right here, and I'm going to do a little side work with it, okay, just for that boxed piece right there, that would be the integral of x over w, 1 over 2x dw. Oh, sweet. Gone, gone. So I have a 1/2 the integral of 1 over w dw, and that would be 1 over 2 the natural log of the absolute value of w, which would be 1 plus x squared plus c. Okay, so believe it or not, it took a lot of work for that one, but let's be honest, that was kind of fun, right? You got to do a little backwards Zorro, and so my final answer for this bad boy, sweet, it ran out, awesome. So my final answer for this would just be this stuff, right, minus that stuff. Can I rewrite it here with my finger? Let's check it out. Oh, snap. Oh, that's not bad. Minus, right? And then you got to take all that stuff. So it would be 1 over 2, the natural log. I don't really need the absolute values if I want to be fancy, because that's always positive, plus c. And you know what's crazy? If you take the derivative of that craziness, for example 5, guess what you get as an answer? You get that. Seems like it's impossible, but you do. Now, as I pull up yet another screen, try example 6 on your own. All right, class, looking at this, example 6 and example 7. I'm not going to, we just did like 5 of these guys, so I'm going to have you guys do those on your own, okay? And remind me tomorrow in class to make sure we do those in class, okay? Or at least have somebody put them on board. We'll go 6 and 7. You put them on board, you get some bonus. Okay, here's example 8, right? This is the actual problem from Stand and Deliver. Okay, I'd rather get to this problem and then show you guys this shortcut of Zorro. Okay, but watch what happens here. Okay, we're going to do this one by integration by parts. So we do our Lippett, right? Is there a log? No. Is there an inverse trig? No. There is a polynomial, though. So we're going to let u equal x squared. That means my dv is equal to my trig, which would be sine x dx. Now, this one's a lot of fun, and you're going to see why. All right? And then we go du equals 2x dx, and the antiderivative of sine would be, that'd be negative cosine, right? You always want to check what's the derivative of that. It is that, so I know I did it right. And then we're going to backward Zorro this bad boy. So the original problem, which is x squared sine x of dx, is equal to those two guys, which would be negative x squared cosine x minus these two guys. So if I'm really, I'll put it here. I don't want to confuse anybody, but it'd be negative cosine x times 2x dx, right? And I should reorganize this stuff. So I get negative x squared cosine x. I'm going to bring out that negative and the 2, so you get that. And then you get x cosine x dx. Now, guess what? I can't do that. Oh, yes, I can. Because I can backwards Zorro that bad boy. Now, what you should do is, that's the first problem we did today, right, class? So if I go back to my handy, trusty notes and look at example 1, there it is. There it is. There's example 1 right there, right, class? So you would, have this being a test, you would have to do integration by parts again. But if I look at my handy dandy notes, which I've already done, I'm going to write the answer to this. And it was x sine x plus cosine x plus psi, right? So my final answer for this long bad boy would be negative x squared cosine x plus what? Seriously? Plus 2x sine x, okay, plus 2 cosine x plus 2c, which would just be c. And I know it's crazy, but if you take the derivative of that, guess what you get? You get that right there. Seems crazy, but guess what? We are now going to go to the tic-tac-toe, aka tabular method. And guess what? You're going to love it. But even though you're going to see it right now, please remember that you always need to know how to do integration by parts. We'll do some problems where you have to use integration by parts. A natural log problem, that L, when that L comes in, or inverse trig, got to do integration by parts. So be careful. Don't get too happy with the shortcut. And don't get so happy that your pen always runs out. All right, so let's roll tabular method. All right, the way we do the tabular method is you have a U column, okay, and a DV column. That's all you need to know is your U and your DV. And how do I know that? Lippett, okay? No logs, no inverse trigs, but I do have a polynomial, okay? And then my trig is sine x. Okay, or my trig or my other guy, sine x dx, right, class? And then what we do, this is called the tabular method. You just, for the U column, just keep on taking derivatives. Can you believe that thing ran out? There is just no way. This pen is going to drive me crazy. All right, I'm going to try to write it on here. I'm not going to read it. So you just take the derivatives going down, and it will exhaust. Thus, the tabular method's going to work, okay? But it exhausts. And then for the right-hand side, it gets a little bit tougher, but you got to keep on taking antiderivatives. The antiderivative of sine is negative cosine x, right? And you can always test and check yourself by going up, right? If you take the derivative, you have to end up with that, with the step before. The antiderivative of negative cosine x is negative sine x, okay? And the antiderivative of negative sine x is cosine x, right? And I can check it by going this way: derivative, 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 okay? And now here we go. This is what we call the tabular method. So believe it or not, the answer to this problem is equal to this. Check it out. I'm going to make a different color here, and you go diagonal, and then that's going to be a plus sign right there. Okay, so you multiply it by a positive 1. So if I'm x squared times negative cosine x times a positive 1 would give me a negative x squared cosine x, right, class? And then I go like this, and it flip-flops. I'm going to multiply this by a -1. So I have 2x times negative sine x times a -1, which would give me a plus 2x sine x, right, class? And then I go here until it's exhausted, right? So this will be the last one. That I'm going to multiply by a +1, and that would be plus 2 cosine x plus c. And guess what? That is the same exact answer as we did the step before. Seems crazy, but it is. And that is the tabular method. But again, you can't always use it. So make sure you're always good with integration by parts. Let's try the next one. And you know what? Since you guys are so awesome, I know you're going to try it on your own. Go ahead and try example 10 on your own, and I'll be right back at ya. All right, class, if it runs out this time, you're on your own, okay? Let's hope that I can get a couple more examples in here for you, okay? Here we go. Let's do tabular method. So I have my Lippett. U is logs, no logs. Is there any inverse trig? There's no inverse trig. Is there a polynomial? For sure there is. It'd be 2 to the 4th. And is there a, oh, and then that's just the other dude. But this U column is all derivatives. How about it? We get to show that we remember everything we've ever learned. Oh, snap. Could you imagine doing this one by integration by parts? Oh my God, you'd have to go over and over and over and over and over again. No, that's why we have the tabular method. Be really careful when you do antiderivatives, but the antiderivatives of this is that, right? 1/4, okay? Hopefully you see there's a little bit of a pattern for sure, but what should I do to ensure that I am doing this 100% correct, right? You should take derivatives. Just take the derivatives. And if you notice it, it does. That works itself out. And believe it or not, so what the heck is the answer? The answer is the integral of t to the 4th e to t dt is equal to booyah, right? And then I'm going to multiply it by a +1. So that'd be 1/2 t to the 4th e to the 2t. Okay? And then it's this guy, but I'm going to multiply it by a negative. So that'd be negative. And I think you guys can handle 4 and a 1/4 will give me a 1. So I'm going to go t cubed e to the 2t. Okay? And then I go these guys, and I'm going to do that by a plus sign. And that's 12 eighths. 12 eighths reduces to 3/2. So we're at plus, I'm going to come down here, okay, class? Plus 3/2 t squared e to the 2t. Okay, and then we got these two guys, and that would be multiplied by a negative, so it's minus. That's a 20/18. Those both have an 8 in it. So since they both have an 8 in it, that'd be 3/2. Ooh, I feel like I made a mistake, right? I did this one here. That'd be 12/8. They do not both have an 8. They both have a 4 in it. So that's still 3/2. Oh, this is still 3/2. So that's 3/2. But it's t e to the 2t, right, class? And then this is my last little piece here, and I'm going to multiply that by a +1. 24/32. They both have an 8 in it, and that would be 3/4. So it'd be a plus, right? Because you're going to multiply it by a positive, plus 3/4. No, t e to the 2t plus c. You know, it's crazy. You find the, I feel like I made a boo-boo on that one. Let's check out the skills. Okay, I got my little handy dandy answer key right here, and I have 1/2 t to the 4th. Booyah, booyah, booyah. Money. Okay, that would just take forever, right, class? If it was integration by parts. So that's why we have the tabular method. It's a big time shortcut. So when you can use the shortcut, you better use it. Got it, class? All right, here we go. 11. Now 11, what a great example. 11 is a great example of the tabular method won't work. And I'm going to show you guys why it won't work, okay? So let's do that in blue over here. Because if I do this correctly, my u's got to be the natural log of x. And my dv, right? My dv would be x to the 3rd, right? And this is okay. You know, you could take antiderivatives here. But the one thing you notice when I take derivatives, okay, right, that's x to the -1. That would be negative x to the -2. Nothing exhausts. And when nothing exhausts, that means the tabular method won't work. So the only way to do this problem, and your hint is because it has a natural log in it, is by doing integration by parts. So what's integration by parts then? Well, it's u is equal to the natural log of x Okay, and they give me some initial value stuff. That just means when a C comes up, I'm going to find that, right, class? And that means dv is equal to x to the third dx, right? And so I have to do my backwards 0, okay? And then du would be equal to 1 over x dx, and my v would be 1/4 x to the fourth. And then I backwards 0 this bad boy, right? Shame on me. You always have to do it when you're about to do it. Okay, and that would be the problem, which would be, we're separating our variables, right? I guess I should have done a better job of separating my variables here. And then as I notice when I'm doing this, right, class, I made a big boo-boo, right? Or those guys, oh no, integration by parts, we're good to go, but that's a z, right? So just make sure we do that when we do notationally. So the antiderivative of this side right here would just be z, right, class? So it's going to be z equals at the end. And then I had to take the antiderivative of this. And taking the antiderivative of this, oh, we need some integration by parts. Therefore, we do this. The tabular method obviously didn't work because nothing got exhausted. So now we officially backwards 0. Okay? And backwards 0 is the original problem. The antiderivative is equal to this, which would be 1/4 x to the fourth natural log of x, right? Minus this, which would be, I'm gonna save myself a step. I'm gonna bring the 1/4 out, and it'll be the integral of x to the fourth over x, which would be x to the third dx. Hopefully you guys were okay with that. I'm not gonna add a plus c yet, just because I have this piece right here, and awesome, I ran out. Oh, sweet! Okay, this is gonna be our last one, okay? And then we do that guy right there. Okay, so we are at z equals, okay, 1/4. Actually, I'm not, oh, snap. Let's just do this part, right? That's 1/4 x to the fourth plus c, right, class? And I still have a 1 to the fourth on the outside. So that would be 1/16, correct, class? Now that is getting way too messy. I'm going to attempt to do this one more time. All right, class, so I apologize, but here we go. If you followed that, and I will finish it with you guys, you should get z is equal to 1/4 x to the fourth, right, class? Natural log of x, and you have the notes right there with you, so I'm looking at off my notes. Minus 1/16 x to the fourth plus c. And then what do I have to do? C came up, so let's find c. I'm going to plug a 1 in for x and a 5 in for z. And if I do all that, if I plug a 1 in there, it's going to go away because the natural log of 1 is 0. And so I get this, because I'm going to put a 1 to the fourth plus c. So you get c is equal to 5 and 1/16. Okay? So remember, what do? We come back in here, and we rewrite our final answer. And then I should check it to make sure I got it correct. Okay? Plus 5 and 1/16. And I wrote it like that for a purpose. It's easy to check. Right, let's plug in a 1. You plug a 1 in here, you get 1/16. You plug a 1 in here, you get 0. So you get a negative 1/16 in that, and you do get 5 is what we were supposed to get. Oh, snap, sweet, it works. All right, come on, get me through one problem. Okay, example 12. Here we go. Let's go. Give me them toes. Maybe that's all I had to say. All right, here we go. It says find the average value. We all know in AP Calc, when you hear the word average value, you immediately say the integral divided by the interval. Right, class? Okay, so there we go. There's our integral, and we divide it by the interval. Okay? Booyah!